Hello, and welcome to Sudoku Adventure number 800. I have the honor and privilege of doing this because Rangsk set the puzzle, so I suppose it would be a little unfair for him to solve it. I haven't looked at it yet, so let's go over the rules together. So we have normal 6x6 rules, so we need to put the numbers 1 through 6 in every row, column, and box of the grid. The blue lines are region sum lines. You'll see these fairly often. And so what this means is each box that this goes through, let me just highlight these. So this line, for example, goes through 4 boxes. The boxes are just the little collections of 6 cells that are a 2x3 rectangle like this. The sum is the same. So these two digits have the same sum as these two, have the same sum as these two, have the same sum as these two. So that is how that works. And now each line works like that. However, each of the lines functions independently. Also, in this particular case, just so that it's clear, this one, it functions, if you've seen it, a lot like an arrow, where this digit is the sum of these two, because there's only one cell in here. Okay. I see that Rangsk has used the Sudoku Maker feature to make this look more like an 8. Okay, and then we also have sandwich clues. So digits outside the grid, that is this 800 for the 800th episode. By the way, I have to say 800 is a lot of episodes. That indicates the sum of the digits that are placed between the 1 and 6 in that row or column. In this case, the 1 and the 6, they could be something like that, for example. In this instance, between the 1 and the 6, we have a 3, 5, which is equal to 8. Okay. And that, I believe, is all the rules. So the link is below if you want to try it. And let's give it a go. So I think actually just typing in that example of the 8 actually gave me the idea that actually the thing I typed is essentially the only way to make an 8 sandwich, because you can't put an 8. Like I can't do that because there isn't an 8 in a 6x6. And so I need to make a 2-cell sum to 8. Well, I can't do 1, 7. 2, 6 doesn't work either because the 6 is one of the crusts of the sandwich, so I can't use that. So the only way I can sum to 8 is this 3, 5. You might think, could you use 3 cells? But the answer is no, I can't use 3 cells. Because if I use 3 cells, then I'd need a 1. Because if I don't use a 1, then my 3-cell minimum would be 2, 3, 4. We also have to keep in mind that the 0 clues here mean that the 1 and 6 are next to each other. But the thing I wrote, I noticed specifically did not work. Because if I make this my sandwich, then the sum for the line is 8. But that's a problem because of this 1 would need a 7. Though I guess, just thinking about this, maybe this would actually be fine. My hope was to prove that this wasn't where the sandwich started, but I realize now I don't think I can actually prove that this isn't where the sandwich starts, because this order, I think, would work out okay as best I can. At least at first glance, it looks like 8 is an okay sum for this to have. Now, it should be noted that sort of the minimum sum here, if I just sort of write down the minimums, is maybe the question... Sorry, I know I'm bouncing around all over the place. The minimum sum here, because this sum, whatever it is, needs to be made in 2 different ways. 5 is the smallest number you can do that with. And 9 is the largest number you can do that with. So these sum to something between 5 and 9, meaning the outies here sum to something between 11 and 3. But this number here is at least 3, I see. So this is from 3, 4, 5, 6 because it's a minimum 1 plus 2. Now, it's possible that I meant to think about the sum of these 3 digits together, because the sum of these 3 digits together is actually the same as the sum of these 4 digits together. I don't think that's all that interesting, if I'm honest, because this is summing to at least 10, but this could very easily sum to at least 10. So I don't think that's quite where it is. Like, this number can't be a 6, I realize. The 1 and 6s being next to each other here is kind of interesting. I could even do, like, these are both a 1-6 pair, potentially, as I look at this grid. That doesn't look too interesting. Okay, so I'm interested in where the 1 goes in row 8, because of the reason that I mentioned before, it's a little restricted. So I don't think this can be a 1, because if this was a 1, now, as mentioned, this row has to go 3, 5, 6, but there's no combination of these that equal the same as these. And you can see that either by noting that this sum is even and this sum is odd, or by noticing, just checking the options. This could be 4 and 11, which aren't equal, or 6 and 9, which aren't equal. So that can't be 1. And this, we already argued at the beginning, can't be 1, because if it was 1, then we'd need, in order to fit the 3, 5. There's not enough room for the 3, 5, 6 over here. So the 3, 5, 6 would have to go over here. And then we noted that that made this 8 with that. So this isn't 1 either. So we can actually corner mark the 1 over on this side. Also, I noticed a thing that I probably should have noticed before, which is that the 3 and 5 are between the 1 and the 6. So I know this actually never sums to 3 or 5. This is only ever a 4 or a 6. And so it's maybe worth noting that. This can't be a 6, though, for the same reason that we've been saying, because if this is a 6, then this is a 3, 5, and a 1, and it's exactly the same as my argument that this cell couldn't be a 1. So this actually just is a 4. That's really weird. This is a bizarre confluence of things to have happen, but I think this just is a 4, because let me just write this in real quick. So if this is a 6, this is a 3, 5, and that's a 1. And again, now that's a 7, and that doesn't work. I have a feeling Rangsk probably thought about this slightly differently than the way I'm explaining it, but maybe Rangsk thought about it that way. But I'm wondering if there's some sort of parity argument that I'm missing. But I'm going to go ahead and note that this is my first digit. So this is a 4, which has the bonus that it makes these a 1-3 pair, because there's only one way to make 4 when you go to do this. Okay, so now this can't be a 1, because we said the 1... Oh, actually, this could never have been a 1 for the same reason that we've been saying. Okay, so if this is a 1, then this is now a 3, 5, 6. And that doesn't work because that 1, 3, 5, 6 has an odd sum. I probably should, for content, say what it is. It's 15, I believe. It's either right, in which case you're amazed at my ability to add 4 numbers together, or it's wrong, in which case you're amazed at my inability to add 4 numbers together. But I think 1, 3, 5, 6 is 1, 3, 5, which is 9 plus 6 is 15. And the problem with 15 is that it's odd. So to say the same thing I was saying before, just slightly differently, these 4 cells definitely have an even sum. And so that means that you can't make them 1, 3, 5, 6. Or to say it a different way, these have an even sum, that has an even sum, and so therefore this digit is odd. It has to be 1, 3, or 5, because the sum of a row in this puzzle is 21. 1 plus 2 plus 3 plus 4 plus 5 plus 6. So that works. Okay. So now, though, this can't be 1. In fact, actually, just to say this, just to repeat the logic from before, the 3 and the 5 are between the 1 and the 6. So this is an odd number that's not 3 or 5. This has to be the 1. Okay, it's basically the point. And so now that's 3, 5. That is 6. And that's 2 in order to make that work. Okay, so these are from 2, 4, 6. Okay, so this sum on this line is definitely even. And this sum is 8. Okay, so this is a 2-cell sum to 8. That's not 3, 5 because there's a 3 in the box. And so that makes this have to be 2, 6 as well, because as we said, there's only 2 ways to add to 8 in 2 digits. So this is a 6 and a 2. These now can be 2, 6, possibly. Or they can be 3, 5. By the way, I noticed that just by Sudoku, 4 goes there. Oops. 4 goes there in this box, and 5 goes there. Okay, these are 1, 3, 5. Just for the column. I wanted to use that parity trick because it seemed relevant. These have an even sum because they're both even, so therefore these also have an even sum, so these have to both be odd. I guess that is just also just saying that the digits left in this row are 1, 3, 5, so you probably shouldn't be too impressed with that deduction. If I'm completely honest. In any event, though, actually, I can note that this digit definitely isn't a 4 now. Okay, so that does actually help a little bit because it tells me this digit's not a 4. This digit also has to be odd. And so therefore that digit is the 4 for this box. And so these 2 digits we now know are 2 and 6. Oops. Okay, bouncing around over there. Oh, by the way, I realize I completely forgot about a clue. And so some of you may have noticed this already, but the 6 and 1 go next to each other in this row. Well, that's the 6, so that had better be the 1, or they don't go next to each other. Fun fact. Okay, and so that's very big because that actually tells me that this sum is not 3, 5. It's 2, 6 as well. So that's a 6 and that's a 2. Okay, so now we get some more digits dancing around the grid like that. Okay, so that is now a 1, and I can give you 2 proofs of that. One is that 1 goes here by Sudoku, and the other of which is that the 1 and 6 need to go next to each other in this row by this clue. So I think this 0 was actually unnecessary. I think this 0 was here for thematic purposes only. That is my current hypothesis. I might be wrong. We might have used it somehow, but I don't think we did. So these are 3, 5 for the box. Okay, so, oh, by the way, at some point we noticed, or we learned that these are a 1, 5 pair, and those add to 6. So those are a 1, 5 pair, and therefore this is a 3, because these need to add to 6, and if I'm going to make 2 digits out of 1, 3, 5, add to 6, I need to pick the 1 and the 5. Okay, this is a 2 or a 4, so this also needs to be a 2 or a 4. In particular, one other thing you could say is you're definitely not putting a 6 in your 2-cell sum to 6 because it would have to go with a 0. So that's a 4 and that's a 2 and that's a 6. Okay, so now this is either 2, 4 or 1, 5. I don't think I know which one it is yet. Okay, well, maybe it will help if I fill in that these 2 digits are 1 and 4. Oh, I do know which one it is because it's not 2, 4 because there's a 2 and a 4 in this column. So this is 1, 5, and I know the order. Oops, 3 and 5. Like that. Okay, so there was a more elegant way than my filling in this pair. So that's a 4. This is a 2. That's a 6 and a 2. That's a 6, and that's a 3. and a heart for Rangsk there. 7 solves. I'm guessing people have been testing it. So very lovely puzzle there for number 800. Hopefully you enjoyed that as much as I did. I hope you gave it a try. And thank you always to Rangsk for having me on. I do greatly enjoy collaborating with Rangsk, and it was a great joy to meet Rangsk at SudokuCon. You can check out Rangsk and I set a puzzle together at SudokuCon for an adventure style puzzle. I don't think it was an actual adventure puzzle, so you can go give that a look. I'm guessing Rangsk will probably put a link down below. Also, shameless self promotion. I stream Sudoku a couple days a week, and other puzzles, sometimes pencil puzzles, sometimes other weird LMD stuff. So if you want to stop by for that, we currently have people have submitted submissions for Octaquadri, which are actually 4x4s, so they're littler than 6x6s. So if you want to stop by for that, I stream on Tuesdays and Sundays at 2:30 Central US time, but you can look at that in your own time if you look at my channel. So that is youtube.com/ZetaMathThosePuzzles. Again, I'm guessing Rank has a link in the bottom. So thank you so much, everyone, for joining me on the Sudoku adventure. I'm guessing you'll have Ranks back next episode. So ta-ta for now.